Hello and welcome to this fourth video in our lecture on digital envelopes and pseudo-random number generators. In a previous video, we discussed the properties of random sequences, and in particular, the property of independence. So, the proven way of generating a truly random sequence of numbers, or in our case, a sequence of bits, is to use a true random number generator. And these generators use non-deterministic processes that truly produce random data. And the way they do it is typically by trying to capture some randomness in physical or natural processes, say in the environment of the computer. So let's discuss a little bit more how such a true random number generator could work. Call those TRNG for short. Well, we first have to pick the source of your randomness. So a few years back, companies started building those devices. So Intel did it. There was a group at Bell Labs. So what they did in this particular case is they were actually using for their randomness source the interval of time between a successive disk access request on the hard drive of a computer. And obviously, we have to be careful because the access requests on a good old hard drive are not that random in the sense that they depend on what the user of the computer is doing. But they were actually using some random fluctuations in those access times. And of course, I'm also wondering if they have actually updated this project to work with solid state drive, but that's a different question. Another mechanism that a well-known project used was to actually take pictures of the floating material within lava lamps and using the randomness of those pictures to generate random bits. So as you can see, people are very creative with these mechanisms, but the important thing to realize is it is not easy to capture truly random data. So in general, the process works like this. A true random number generator has to use a true or a source of true randomness. And that's, like I said, typically it's a physical process in the outside world. And then what they do is they basically feed this randomness into some kind of processor that somehow is able to extract that randomness and to output a random bit stream, a sequence of bits, which can then be used by a cryptographic algorithm. So what goes in that box depends actually on the process that is chosen to capture the randomness. But in the simplest possible case, it would simply be an analog to digital conversion. In other words, you're taking some physical quantity that you're measuring and you just convert it to binary. I make this sound pretty simple, but actually it is not simple. And this is the reason why we're going to discuss another way of getting random numbers. But if you're doing this way, then there's quite a bit of work involved in, first of all, capturing this environmental randomness and then converting it into bits, especially into as many bits as the users are going to need. So if you don't have access to one of those devices, another way you could get truly random data is by going to random.org. That's a website that provides true randomness for you. So if you look on the right here, you're able to pick your minimum and maximum bounds. And for example, if you want a random number between 1 and 1,000 or a million, you can just click here and it will give you one number at a time. So the first thing to notice is that it takes a little while to get each number. Now, of course, there is a delay because of the web connection, but it turns out there's also a delay because of the time it takes to generate the random bits. Now, before we move to that, notice in this case, the way they are getting randomness, true randomness, is by capturing atmospheric noise. So the way they actually do it is they have a bunch of radios, these good old radio sets that are basically tuned to frequencies that are in between actual radio stations. So they are just picking up on random noise in the atmosphere, and they're converting that to random bits. So the problem is that, as I just mentioned, it takes a little bit of time. So if you go to the FAQ, you notice that there is a limit to the amount of randomness you can actually request from this website. And the reason for that is because the sources they are using, those radios, only generate about or up to 12,000 bits per second. So remember that in cryptographic algorithms, which are used billions of times every day, we do need these random numbers quite a bit. So the bottom line is to realize that getting truly random data is actually pretty costly, both in terms of times and computation and so on. So what we're going to do in this class, which is what most cryptography applications do, at least in many cases, is to give up on truly random number generators and use pseudo-random number generators, okay, which can abbreviate like this, PRNGs. And so we just want to briefly discuss in this video the general structure of this random number generators, and then in the next video we'll look at a specific example. So because these are not truly random, they're only pseudo-random, they are not tied to an actual source of true randomness. And by the way, another name for this sources of true randomness is entropy source, in case you see this expression in your readings. So we're not going to try to find and exploit an entropy source. We're just going to actually use a good old algorithm. And in particular, we're going to use, just to make sure to emphasize that point, a deterministic algorithm. So an algorithm that does not include any randomness in it. Okay, so the way these deterministic algorithms work is they take as input a single number, usually called the seed, and then they feed that to the algorithm. And this deterministic algorithm is going to output a sequence of pseudo-random bits. And the way they typically work is that they work in stages, starting from the initial number, which could come from either an entropy source or just a pseudo-randomly picked seed number. So they're starting with this number, they're going to produce one number at a time in stages. And what's going to happen is the output of one stage of the algorithm is going to be fed back as input to the next stage of the algorithm. And so this is a very generic pattern for pseudo-random number generators, and we're going to illustrate it in the next video when we discuss the BBS algorithm.